Hello, ARRL members and QST readers worldwide. I'm Dave Kassler, the author of the Ask Dave column, and my call sign is KE0OG. In the June issue of QST, which I have here, the first article was about antennas and feedline options. And I thought what I would do today is put together a few charts that talk about the transmission line for Windows program, and maybe we can just have a little fun with it. So let's look at the charts. We're going to take a look at a so-called backyard dipole, a simple dipole. And this is an optimum dipole for 20 megahertz. It's 1/2 wavelength long and 1/2 wavelength high. So if we look at the entries here, we see the ends. It's 34 feet wide and 34 feet tall, number 12 wire. And so we're going to look at a couple things about this antenna. First of all, it's a beautifully matched antenna. It's got a low SWR 1.43 at 14.2 megahertz, and it's under 2-to-1 across the entire band. You could hook your transceiver up to this without any problem. Look at the input impedance right here. This is Z for impedance. It's 71.28 ohms, and the imaginary component is minus J 1.832 ohms. Okay, so that's what that is. But let's look and see what happens when we put a real transmission line in here, okay? This chart, which shows TLW, or the transmission line program for Windows, shows the use of a very common coax, RG8X, and 100 feet of it, which is a common length you can get into it. And I will tell you, when you take a look at all the twists and turns that your feed line takes getting from the transmitter to the antenna, this is quite a reasonable number. Now, we put that 71.28 ohms and the minus 1.832 reactance ohms at the load right here, okay? So the SWR at the load, which we saw from the numbers on the last chart, is right here, and the SWR at the line input is 1.3. Now, here you'll notice that the total line loss is 1.3 dB, and you add about 0.06 due to the feed line. Now note the input impedance, 38.39 minus J 1.98, or 38.44 ohms at minus 2.95 degrees, okay? Now note that this is being fed by a 50 ohm transceiver, so that's what you'll see. Now we can flip this just for kicks. Let's take the input resistance and take the input resistance from right here, 38.39 minus J 198, and put that in here as the input impedance, and then the impedance at load, 71.28 minus J 190, exactly matches what we had up here, okay? So what I'm saying is, it is possible, if you know the length of your feed line and what kind of feed line it is, okay, you can determine what the actual input is at the load. Notice here that the load has something near 70, and by the time you get it back to the input, it's 38. You go, wow, okay. Well, the SWR at the load, this is right at the input to the antenna, is 1.43, okay, and that 1.43 is the SWR at the load. Notice that even though it's 71, it comes down to 38. Now, can we do this backwards? Yes, we can do it backwards. We put the numbers in here and found that the numbers work both backwards and forwards. Just for kicks, Note that this right here, we have a 71 ohm antenna with very little reactance, okay, being fed with a 50 ohm line. There's an alternative here where we can feed it with 75 ohm line. And if we do that, if we select the 75 ohm line, this is what happens. The impedance right here at the SWR is 1.067. It's very, very good. Okay, and we get the, again, 71 ohms and so on. That's all the same. But now if we put this into transmission line for Windows and we use an RG11 cable, which is a 75 ohm cable, okay? So what we find is that the SWR at the load is 1.08, SWR at the line input 1.07, impedance at input 74.3. Well, now you're going to want to turn on the antenna tuner in your radio so that we can just tweak this out and make this look just absolutely beautiful. The software over here, you can actually look at what elements would be involved in a tuner. If you really wanted 50 ohms here and 74 ohms here, this would give you a 1-to-1 SWR. There's 50 ohms looking in here, and the correct impedance looking in there, the impedance that we see right there shows up right over here. Now you'd have to find exactly these values. What would be easier is using the tuner built into your rig or a small external tuner. What have we learned? We've learned that using transmission line for Windows, knowing the length of your coax, you can take the resistive impedance and the reactive impedance at the feed line and discover what the input impedance is at the actual antenna. We don't need any special lengths of stubs or anything like that, just using this. Note that you do need an accurate length. Now that goes all the way from the back of the transmitter through whatever routing you have in the shack. For example, in my shack, the back of the transmitter goes over to the input to the amplifier. The output of the amplifier goes into a little box that measures the SWR. And then it goes from there up to a switch, and then it comes out of the switch and goes to the antenna down through a box on the outside of the house that's got the lightning arresters, and then the cable is strung across the backyard. You've got to take all of that into account. But if you do and you make that measurement, it's very easy to tell what is going on at the antenna versus what is going on at the feed line to the antenna where the input is. And the numbers work if you go the other way too, and you happen to know the input impedance for the antenna, you can determine what it will look like at the feed line input to the antenna system. So, fun things you can do with these various tools. We used two tools. One was Easy NEC. Easy NEC will model an antenna, and Easy NEC is available to you for free at easynec.com. And the reason it's free is because Roy Llewellyn, who used to maintain it, has now retired, and he's just put it up there. He won't be doing any further maintenance on it, but it's a really solid piece of software. The other piece of software is Transmission Line for Windows, which first showed up in 2014 in its present form in the antenna book. So it's about 10 years old and again works fine. It does have provisions in there that you can input the parameters for a new piece of coax that doesn't show up in there, and come up with some great stuff. So there you have it. We were able to get some real good ideas of what the impedance was in and out of this transmission line and antenna. I would like to say thank you for following along in this video and for reading the Ask Dave column. I invite you to join the ARRL It's a great organization and does a lot more than just publish a magazine. So, until we next meet, 73.